In this video, we're going to talk about budget constraint, opportunity costs, and the law of diminishing marginal utility. So we're going to cover this through an example problem. Lisa has a budget of $20 to spend on food and transportation for the week. The cost of a cheeseburger and a train ticket are $4 and $2 respectively. What is the maximum number of cheeseburgers that she can buy? To determine the maximum number of cheeseburgers, take the budget that she has and divide it by the price of each cheeseburger, which is $4. So 20 divided by 4 is 5. So that is the maximum number of cheeseburgers that she can buy. Now, when creating the budget constraint graph, here's what you can do. First, you want to draw the y-axis and the x-axis. So the x-axis is the horizontal axis, the y-axis is the vertical axis. Now in this graph, we are going to put cheeseburgers on the y-axis. And then train tickets, we're going to put that on the x-axis. So the maximum number of cheeseburgers that she can buy represents the y-intercept along the y-axis, which in this example, that's going to be 5. Now let's calculate the maximum number of train tickets that she can buy given her budget constraint. So take the budget, $20, divided by the price of each train ticket, which is $2. So the maximum number of train tickets that she can buy is 10. Now I may have to extend this graph in order to draw this graph according to scale. So 10 should be somewhere in that area. Now all you need to do to draw the budget constraint graph is connect these 2 points with a line. So that's the most simplest way in which you can draw a budget constraint graph. But now if you want the additional points on this graph, it's helpful to create a budget table, which we're going to do that in part C. So first, we need to come up with an equation that will help us to create the table. The budget allocated between 2 items is the price of the first item times the quantity of the first item plus the price of the second item times the quantity of the second item. So let's say the first item is the cheeseburgers, the second item is the train tickets. In this example, the budget is 20. The price of each cheeseburger is $4 times Q sub C to represent the quantity of cheeseburgers that she can buy, plus the price of the train ticket, which is $2, times the quantity of train tickets. Now, we need to solve for one of these 2 variables. We can either solve for QC or for QT. Which one should we solve for? What would you say? QC or QT? Keep in mind, C is on the y-axis, T is on the x-axis. In algebra, typically, you would usually solve for the y variable. You would want to get y by itself, or y in terms of x. So in this case, we're going to solve for QC because it's associated with the y-axis. So we got to get QC by itself. First, I'm going to move this term to the other side. As we move that term from the right side to the left side, the sign is going to change from positive to negative. So we have 20 minus 2QT is equal to 4QC. Now I want this term to be on the left side of the equation. So what you could do is just simply reverse the equation. This equation is equivalent to 4QC is equal to 20 minus 2QT. Now to get QC by itself, I need to get rid of the 4. The 4 is multiplied by QC. So to separate it, I need to divide by 4. The opposite of multiplication is division. So I'm going to divide every term by 4. 4 divided by 4 is 1. So we just get QC on the left. 20 divided by 4 is 5. and 2 divided by 4, or 4 divided by 2 is 2. So 2 over 4 reduces to 1 over 2. So we get QC is equal to 5 minus 1/2 QT. Now what we're going to do at this point is we're going to reverse the two terms in this equation. So we can rewrite it as QC is equal to negative 1/2 QT plus 5. Now the reason why I did that is to put it in slope-intercept form. That is y equals mx plus b form. B represents the y-intercept, which we can see as 5. M represents the slope, which is negative 1/2. And so that answers the first part of part D. What is the slope of the budget constraint? So I'm just going to write that here. The slope is negative 1/2. We'll talk about what it represents later. So now we can use this equation to create the table. So I'm going to plot QT, or in other words, X, and then QC, or Y, and then the point that it corresponds to on the graph. So let's plug in 0 for QT. If you plug in 0 into this equation, you're going to get the y-intercept, which is 5. We'll call this point A. Now what is the next point that we should plug in? I wouldn't plug in a 1 because you're going to get a fraction. Notice that the denominator is 2. So instead I would go by 2's. So the next point that I will plot is 2. If you plug that in to QT, you'll get that QC is equal to negative 1/2 times 2 plus 5. Negative 1/2 times 2. 2 times a half is 1, but this is going to be negative 1. So negative 1 plus 5 is 4. So this will give us point B. Now, let's plug in the next point. So going up by 2, so the next one is going to be 4. So if we plug that in back into QT, we're going to have QC is equal to negative 1/2 times 4 plus 5. So what is negative 1/2 times 4? 4 divided by negative 2 is negative 2. And negative 2 plus 5 is 3. So this will give us point C. At this point, we could see a trend emerging. Notice that as QT goes up by 2, QC goes down by 1. So when QT is 6, QC is going to be 2. When QT is 8, QC is going to be 1. That will give us point E. And when QT is 10, QC is going to give us 0, point F. So we have 6 points on the line. That is points with whole numbers because you have an infinite number of decimal points on the line. So let's go ahead and plot it. So this is going to be 2, 4, 6, 8, and then 10. And then 1, 2, 3, 4, and 5. So the first point is at 0, 5, and then 2, 4, and then 4, 3, and then 6, 2, 8, 1, and 10, 0. So this is point A, B, C, D, E, and F. So now you know how to create a budget constraint table and the graph with all the whole number points on it as well. So now that we're finished with part C, let's move on to part D. What is the slope of the budget constraint? We know that it's negative 1/2. The slope of all budget constraints will always be negative. Whenever you have a slope of 0, you have a horizontal line. A slope of 1 is a line that increases at an angle of 45 degrees. A slope of -1 goes down at 45 degrees. Because anytime you have a budget constraint with two items, you're always going to have a line that goes in this direction. Now it can vary, but it's going down, so the slope is always negative. Now what does the slope of the budget constraint represent? What would you say? The slope of the budget constraint graph represents the opportunity cost. Now, is this the opportunity cost of purchasing a train ticket or a cheeseburger? What would you say? It's going to be the opportunity cost of the item on the x-axis. So that is the opportunity cost of purchasing a train ticket. Now let's talk about what opportunity cost, what it is, like what it represents. The opportunity cost represents the value of what you give up in exchange for acquiring another item that you desire. So in this case, the opportunity cost of a train ticket is -1/2. That is, if you wish to purchase an additional train ticket, you have to give up half of a cheeseburger. So increasing the number of train tickets by 1 means that you have to lose half of a cheeseburger. If we multiply everything by 2, that means that buying 2 additional train tickets costs us 1 cheeseburger. And we could see that in the table. As we gain 2 train tickets going from 2 to 4, we lose a cheeseburger, 1 cheeseburger. So that is the opportunity cost of gaining 2 train tickets. We have to give up a cheeseburger. So this leads to part E and F. What is the opportunity cost of purchasing an additional cheeseburger versus an additional train ticket? Well, we know the answer for F. The opportunity of let me say that again. The opportunity of purchasing 1 additional train ticket is the cost of giving up half a cheeseburger. So that's the answer for part F. Now, what about part E? What is the opportunity cost of purchasing an additional cheeseburger? Well, we need to reverse it. We could use this part. If the opportunity cost of purchasing 2 train tickets is giving up 1 cheeseburger, then the reverse is true. The opportunity cost of acquiring 1 cheeseburger is giving up 2 train tickets. So this here is the answer to part E, and this part here is the answer to part F. So just let's review so you're not confused on these 2 questions. First and foremost, the slope of the budget constraint graph represents the opportunity cost of acquiring an additional item on the x-axis, the horizontal axis. So it represents the opportunity cost of 1 additional train ticket. And the opportunity cost of 1 additional train ticket is 1/2 of a cheeseburger. Because in order to acquire 1 additional train ticket, you have to give up half of a cheeseburger. And for E, we're looking for the opportunity cost of just purchasing 1 additional cheeseburger. To buy 1 additional cheeseburger, we need to give up 2 train tickets. So if we're going from point E to D, to increase the number of cheeseburgers from 1 to 2, we have to decrease the train tickets from 8 to 6. So that is the opportunity cost of purchasing 1 additional cheeseburger. You have to give up 2 train tickets in order to get it. So hopefully that helps you to see the concept of opportunity costs. It's what you must give up to obtain what you desire. Now let's move on to part G. Describe what happens to the marginal utility of purchasing an additional cheeseburger versus purchasing an additional train ticket. So let's start with purchasing an additional cheeseburger. Would you say the marginal utility goes up or down? Well, the answer is that it goes down. As the number of cheeseburgers that you purchase increases, the marginal utility will decrease. However, because the number of cheeseburgers that you're purchasing goes up, the number of train tickets go down. And so the marginal utility for that will go up. And there's something called the law of diminishing marginal utility. The basic idea is this: the more you buy of something, the more of something that you buy, the less useful it becomes to you. That is, the less useful each additional unit becomes to you. So for instance, let's say if you're hungry, you're very hungry, the first cheeseburger you buy will be very satisfying because it satisfies your hunger. If you purchase a second cheeseburger, it may still satisfy you, but not as much as the first cheeseburger. By the time you're eating the fourth cheeseburger, you won't get the same satisfaction. The fourth cheeseburger will have less utility to you. It will be less useful to you than the first cheeseburger. So the more cheeseburgers that you buy, the less useful it becomes. And so that's the concept of the law of diminishing marginal utility. For each additional unit that you buy, the utility of that additional unit decreases. So, as we purchase additional cheeseburgers, the marginal utility goes down. But as we purchase additional cheeseburgers, we're less able, or we're not able to purchase more train tickets. In fact, we can purchase less train tickets. Because this goes down, the marginal utility of the train tickets go up. Now the reverse is true. If we purchase additional train tickets, the marginal utility of those additional train tickets will go down. And as we purchase more train tickets, we're going to purchase less cheeseburgers. So the marginal utility goes up. So anytime the quantity of something that you purchase goes up, the marginal utility goes down. If you decrease the quantity that you purchase, the marginal utility goes up. So marginal utility is inversely related to the quantity of an item that you purchase. The more train tickets that you purchase, the less useful each additional train ticket will be to you. So in the case of train tickets, in this example, Lisa can purchase a maximum of 10 train tickets. But let's say if she works 4 days a week, only the first 4 train tickets will be useful. If she purchases an additional train ticket, let's say the 5th one, when she doesn't need it for work, it's going to be less useful for her. Maybe she wants to ride the train to, pass the time, but it's not as useful as the first 4 train tickets. And so as the number of train tickets that she purchases increases, the utility or the usefulness of each train ticket decreases. Now let's look at it from a graphical perspective. As we travel from point B to point E along this graph, the number of train tickets goes up. So thus the marginal utility of the train tickets will decrease. However, as we travel from B to E, the number of cheeseburgers that are being purchased decreases. So the marginal utility of the cheeseburgers, that's going to go up. So you need to be able to answer the effect of marginal utility as you move in one direction of the graph or if you move to the other. So let's say if we were to move from point D to point C, what happens to the marginal utility of the cheeseburgers? Well, because the quantity of cheeseburgers are increasing, then the marginal utility of each additional cheeseburger that we buy, that is going to decrease. Now let's work on another example problem. Sam has a budget of $54 for movie tickets and sandwiches. The costs of a movie ticket and a sandwich are $9 and $4 respectively. If Sam plans on watching 4 different movies at the theater, what is the maximum number of sandwiches that he can purchase with his remaining budget? So what can we do to answer this question? What formula can help us out right now? So the formula that you want to use is this equation. The budget is equal to P1 times Q1 plus P2 times Q2. So let's say The cost of a movie ticket is indicated by subscript 1, and the second one is going to be associated with the cost of a sandwich. So the budget in this case is $54. The price of a movie ticket is $9 times the quantity of movie tickets, which we'll call Q sub M. The price of a sandwich is $4 times the quantity of sandwiches, which is Q sub S. So now what we're looking for is the maximum number of sandwiches. Now we know the number of movies that he wants to watch. That's 4. So we know that Q sub M is equal to 4. So what we need to do is we need to plug this in to the equation and solve for Q sub S. So replace in Q sub M with 4. Let's solve for Q sub S. If you want to, because this is the variable you want to solve for, you can replace that with an X, for those of you who like algebra. 9 times 4 is 36. Next, we need to subtract both sides by 36. 54 minus 36 is 18. So we have 18 is equal to 4x. So if we divide this by 4, 18 divided by 4 is 4.5. Now, he can't buy 5 sandwiches because that will exceed his budget. And since sandwiches, they come in whole number values, we're assuming that he can't buy half a sandwich. The maximum number of sandwiches that he can buy, that is the maximum number of whole number sandwiches, is 4. So given his budget constraint, he can buy a maximum of 4 sandwiches. Now let's move on to number 3. Jack plans to spend $24 on coffee and sandwiches. The cost of a cup of coffee is $4, and the cost to purchase one sandwich is $6. Draw a graph showing Jack's budget constraint. Well, to do that, we need to calculate the maximum number of coffee that he can purchase. So that's going to be the budget divided by the cost of each cup of coffee. Or we could say P sub C. So the budget is $24, and the price for each cup of coffee is $4. So the maximum number of coffees that he can buy is 6. Now, for the number of sandwiches, it's going to be the budget divided by the price of the sandwich. So the price of each sandwich is currently $6, which means at a budget of 24, the maximum number of sandwiches that he can buy is 4. So now let's plot the cups of coffee on the y-axis and the number of sandwiches on the x-axis. So the maximum number of cups of coffee are 6, and the maximum number of sandwiches is 4. So this is the y-intercept, and this is the x-intercept. And then we just got to draw a straight line connecting the 2 points. So that's all we need to do to draw the budget constraint. Now let's move on to part A. What happens to the graph if the price of coffee changes from $4 to $8? So if the price of coffee goes up, how does that affect the shape of the graph? As the price of coffee increases, the maximum quantity that he can purchase is going to go down. So what's going to happen is we're going to move down the y-axis. So to calculate the maximum number of cups of coffee that he can buy, it's going to be the budget of 24 times the new price of $8. So the new y-intercept is 3. Now to draw the graph, we just connect the the y-intercept to the original x-intercept. So notice the effect on the graph. With respect to the x-axis, the budget constraint line rotates counterclockwise. Notice the area under the curve is less as we move down the y-axis. So that is the effect on Jack's budget constraint graph if the price of coffee goes up. He can buy less cups of coffee in that case. Now let's move on to part B. What happens if the price of coffee decreases from $4 to $2? Well, as the price of coffee goes down, the maximum number of cups of coffee that he can buy goes up. And so to calculate that number, it's going to be $24 divided by the new price of $2. And so the new maximum is going to be 12. So that's the new y-intercept. So notice that this time the curve, or the line rather, it rotates about the x-intercept in the clockwise direction. Before it rotated in the counterclockwise direction. So if the price of coffee goes down, the curve will rotate clockwise around the x-axis, and if the price goes up, the curve will rotate counterclockwise around the x-axis. And as we can see, the y-intercept moves up along the y-axis. Now let's move on to part C. What happens to the graph if the price of a sandwich changes from $6 to $12? Well, let's calculate the new maximum number of sandwiches that he can buy. So given a budget of $24 divided by the new price of $12, he can now only buy a maximum of 2 sandwiches. So this time, the x-intercept moves along the x-axis towards the origin. So now we can draw the new budget constraint graph. So notice, with respect to the y-intercept, the graph rotates in the clockwise direction. Now let's see what happens if the price decreases from $6 to $3 in part D. So if we take the budget of $24 divided by $3, he can now buy 8 sandwiches as opposed to 4. So this time the x-intercept moves towards the right along the x-axis. As for the rotation, this time, going from the red line to the blue line, we can see that the budget constraint graph, it rotates in the counterclockwise direction. So those are the effects of changing the price of coffee and the price of the sandwiches. Now let's move on to part E. What happens to the graph if his budget increases from $24 to $36? What do you think is going to happen? In this case, both the x and the y-intercept will increase. So we need to calculate the y-intercept, which is going to be the budget divided by the price of coffee. So the new budget is $36. The price of coffee is still 4. So now the new value is 9. Now, to get the x-intercept, or the maximum number of sandwiches that he can buy, it's going to be the new budget of $36 divided by the price of each sandwich, which is $6. So we get a new value of 6. So notice that the y-intercept increased from 6 to 9, and the x-intercept increased from 4 to 6. So by increasing the budget, both the x and the y-intercepts, they both increase. So there's no rotation with this graph. The net effect is that the budget curve extends outward when the budget increases. If you were to decrease the budget, let's say from 24 to 12, then it will go this way. So if it's $12, the y-intercept will be 12 divided by 4, so this will now be 3. And for the x-intercept is 12 divided by 6, so this will now be 2. So the blue line represents a budget of $36. The red line represents a budget of $24. And the green line represents a budget of $12. So to summarize what we've just learned here, as the budget increases, the budget constraint line extends outward. As the budget decreases, the budget line contracts inward. I guess that's as far as I can go. Now, let's say we have 3 points. Let me just get rid of this. We're going to say point A, point B, and point C. So notice that point B is on the budget line, point A is below the budget line, point C is outside of it. Which of these 3 points represent a budget that is greater than 24? Which one represents a budget that is equal to 24? And which one represents a budget that is less than 24? Feel free to take a minute and answer those questions. Now remember, as we extend the budget line, the budget increases. Therefore, point C represents a point on the graph where the budget is greater than 24. Now, point B is on the line. Anywhere on the line, the budget will be exactly 24. So if we create a new point, point D, that too will have the same budget as point D. That is a budget of 24. Now, A is below the budget line. As we contract inward from the budget line, the budget decreases. So point A would represent a budget of less than 24. So anywhere inside this area, the budget is less than 24. Anywhere outside of this area, the budget is greater than 24.